everyone, it's Alyssa and welcome to You Can Learn Math. So today is about the commutative property. Commutative property. And the commutative property of multiplication. So right off, I'm going to just explain what that is, just give you sort of the definition. So if that's all you need, you can get it, be on your way. If you'd like to know a little bit more, like to understand it and know why it works, keep on watching. So, commutative property of multiplication says that if I am multiplying two numbers, reordering them doesn't change the outcome. 5 times 3 is 15. 3 times 5 is 15. So that's commutative. I can change the order. That's a way to remember it. That's how I remember it anyway. Change the order and it still is the same. First two letters, C-O, change order. That's my little technique. Okay, so if I change the order, it's still the same. This would also be true if it was a longer string. That's the same as 2 times 4 times 5. That's the same as 2 times 5 times 4. It's the same as 5 times 2 times 4. It's the same as 4 times 2 times 5. And last but not least, I'll write it up here, fine. 4 times 5 times 2. They're all the same. They are all 40. Okay, so let's look now at why this is true. Let's picture if I said 5 times 2. I could do this. I'm going to use a little grid that's already on here on the screen. And this is how I could draw it. Ugh, it looks like creepy teeth. But anyway, so I have 5 blocks and I have 2 stacks of them. 5 times 2. All right, and that is 10. And we can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 blocks here. Well, what if I rotated this? You can visualize like I'm rotating this block. So now 1, 2, 3, 4, 5. That's lopsided. It's the leaning tower of multiplication. So it looks like this now. So just coloring it so you can see how I've rotated it. Boop. Okay. Well, now it's like 2 that's been stacked 5 times. So it's the same thing, just our perspective has changed a little bit. But the blocks haven't changed. So 5 times 2, and this would be 2 times 5. Still the same thing. Well, what about if it is what we were talking about before, something like 2 times 4 times 5? Well, that we can think of three-dimensionally. So let's say 1, 2, 3, 4, 1, 2, 3, 4, 5. I'm trying to make this reasonably and I bobble it at the finish. There we go. There we go. That's better. Okay, that's better. All right. So if we look at this as a three-dimensional thing, I'm quiet because I'm concentrating. There we go. All right. So you can see here, I have, this might be a representation of, like I have this block of 5 and I've stacked it 4 times. I'm just going to highlight all of these. These are the other 3 times that this little block or chain of 5 has been stacked 1, 2, 3, 4 times, and then that's been done twice. So behind it we have the second set. 5 times 4 times 2. Now if we rotated that, if I spun this toward me, I'm going to sketch it quickly, don't worry, I'm not going to draw that whole thing again. If I rotated it towards me, so we had 2, 3, 4, 5, you had like the 2 on this side, and then going into the distance you had the, like that. So I've just spun this block around. Now it looks like I have, let me kind of scoot this over. There we go. It looks like I have this block of 2 that's been stacked 1, 2, 3, 4, 5 times. And then it goes back 1, 2, 3, 4. I have 4 rows of it. So no matter how I'm looking at it, 2 times 4 times 5, 5 times 4 times 2, those can all be represented by rotating this block that doesn't change in space. So basically I'm describing how many tiny cubes are in this block. 2 cubes on this side, 4 cubes high, 5 cubes deep. And no matter how I spin that block in space, the number of cubes in it doesn't change. I now say, oh, this is the front, or this is the height, this is the length, this is the width. But the number of cubes inside doesn't change. So that is commutative property, and that's why it doesn't matter if we change the order, because it really is like, if we see it as a physical object, rotating a square or rectangle, or rotating a cube, or any other combination of shapes that we're using these for. And it doesn't change anything. We're still describing the same items. So that is the commutative property of multiplication. I hope you enjoyed that today. If it was helpful, useful in any way, please like, share, subscribe. You know the drill. Thank you so much for stopping by. Hope you have a great day. See you later. Bye.